Unmatched Mind. This is Vinny. My guest today is Dr. Paul Thagard. Dr. Thagard is a Canadian philosopher and cognitive scientist. Really interesting conversation with Dr. Thagard. I mean, we touched on a lot of different things. We started getting into what the mind is versus the brain. We touched on a little bit of whether animals feel grief and do animals feel emotions in general. And then we really dove into artificial intelligence and machine learning and the ethics of artificial intelligence, which I found really fascinating. We went all over the place a little bit, but the idea that, as machines get smarter and smarter and smarter, they start to approach human-like intelligence, which means some of the problems humans have with making decisions start to apply in the machine world. So, really interesting conversation. I really enjoyed it. I hope you get something out of it. And with that, I give you Dr. Thagard. Well, Dr. Thagard, I appreciate you coming on. Thanks so much for your time. Could you give the listeners, I guess, an overview of who you are, what your background is, and what you're passionate about?
Okay, my name is Paul Thagard. I retired from being a professor of philosophy at the University of Waterloo, but writing full time. I'd like to have the time to write. I've got 3 books coming out this month, so it's been highly productive. But I work in many different disciplines. I started out in philosophy, particularly philosophy of science, but then quickly moved into cognitive science, which is the interdisciplinary study of mind. And I love moving back and forth among philosophy and psychology and neuroscience and computer modeling, because I think that's the best way to understand thinking and reasoning.
For sure, and yeah, and if you kind of draw those circles on a piece of paper, I feel like there's a big overlap in those diagrams at times.
Yeah, and the overlap is really exciting because it's got some of the most difficult questions in all of thought, not just the humanities, but also the sciences. Questions like consciousness and emotions and rationality are ones that
Exactly.
belong to all of those fields.
Right. Yeah, and this is, I mean, as we dig in, and we'll start to touch on this, but in my head, as I'm getting, and again, on this conversation, I'm the layman, right? You're the obviously the expert, and I always go back to in my head as I'm reading, and I think some of the discussion points I had sent you, I kind of noted, hey, when is the science, the science gets very detailed, and at some point, I feel like it reaches a point of, well, we just don't know what we don't know. So we kind of call that the mind, or we call that consciousness, or, as opposed to it just being like, we understand it 100%. We understand it. It's just a physical, ball of neurons in a brain, and we get it all. And it's just a physical system that can be replicated and duplicated once we truly understand it. And so in my, layman's perspective, those two kind of dichotomies where, and I don't know what the science says about that or what, but
Well, one of the things that's really exciting about this is that over the last few decades, the science has just gotten better and better. A lot of the big questions that were open when I got interested in these issues decades ago, I wouldn't say that they're settled, but it's just quite dramatic how much progress there's been on a lot of these really big questions that used to be philosophical, but now increasingly becoming
right.
scientific questions.
Hmm. I mean, is it because of the physical sciences, the understanding the brain more, or is it both from the philosophical perspective as
Oh,
well as
it's really all of them. I think
yeah,
philosophy's advanced, but so a lot of the biggest advances have been in cognitive neuroscience, understanding how the brain works. But
right.
that's had lots of very fertile interconnections with cognitive psychology. So
Hmm.
psychology and neuroscience. And another key part of this has been the development of more and more sophisticated computer models. I mean, it's very difficult to write down a theory of mind, but computer modeling, really since the 1950s, has been a very valuable methodology for trying to
Right.
figure out what's going on in the mind and what's going on in the incredibly complex system that the brain is.
Hmm. Well, so you just touched on something, and the brain versus the mind distinction. I mean,
Well,
that's a deep question, I get, but
oh,
that's what we're
yes,
here
that's a
for, right?
very deep question. Uh, Going back to the great philosopher Descartes, they were taken to be completely separate. In fact, it
Mm,
was, if you go back as far as Aristotle, he didn't think that the brain had anything to do with the mind. He thought the brain was just a cooling organ for the body.
hmm,
But evidence started to mount up that it was at least relevant. For example, if you hit
right.
somebody over the head, then their thinking doesn't work as well as it did.
Right.
Um, but the idea that the mind is the brain it really only got proposed seriously probably in the 1950s, and there wasn't much evidence for it. The kind of evidence you can get is when you get detailed explanations of what the mind can do by figuring out how the brain can do that. And a lot of that has been developed over the last few decades. There's been theoretical advances, there's been experimental advances. Now, for example, we've got experimental techniques uh, like functional magnetic resonance imagery to be able to figure out what parts of the brain are operating. But we've got new theoretical tools, such as the ability to build computer programs of neural networks. So between the theory and the improvement in experiments, then you
Hmm.
get way more reason to believe, now that it's becoming quite reasonable, to claim that, in fact, the mind is the brain.
So they are the same thing. Just
Yeah.
so, yeah, yeah. That's kind of what I, my previous comment was almost like if you go back in history, at one point we didn't know, the brain is so powerful, and our our thoughts, our emotions, our feelings, our self awareness tends to be, maybe hundreds of years ago was much less understood, and we just said, well, that must be this mind thing, connection to God, or some, theism gets in there, and it gets less tangible, less, some things you really can't touch. But I
Well,
feel like as scientists, say again,
hundreds of
yep,
years ago, it was quite reasonable to think the mind was something special, that it was
mm,
spirit or soul, because
right,
there didn't seem to be any mechanical way in which you could explain how it works. But it
right,
was only
right,
in the late 19th century that people figured out that neurons are a big part of what the brain does. And then gradually through the 20th century, people got a better idea of what the neurons are actually doing. And
right.
now I think there are quite detailed explanations you can give of how neurons, which are just simple cells, can interact in complex ways to produce all the wonderful kinds of thinking that minds are capable of.
Yeah, yeah, and we're certainly, foreshadowing to the rest of the conversation. But I had some notes here thinking, well, and this is if eventually we can explain and understand and potentially even prove that, these complex thoughts, these feelings, these emotions, whatever, are really just a series of very complex neurons, akin to transistors in a computer, right? And we'll talk about the machine intelligence in a bit here, but i- if that's all a brain really is, then there should be no reason why we can't duplicate that in a machine. Or, instead of a neuron, we get a transistor. Instead of carbon-based life, we got silicon-based life. But so interesting. We'll jump there as we get into this. But so one of the blogs that first I first found of yours was, the title was "Do Animals Have Emotions?" So, and I think going back and forth through email, I feel like you've had a. Did you mention you had a kind of a change of opinion there?
Yeah, in fact,
Initially,
the blog post I just put up on Friday was on whether animals feel grief. And for me, grief
uh,
turned out to be the kind of wedge emotion, because when I did the blog post that you mentioned on animals feel grief, I wasn't really sure, because I could run arguments both ways. Certainly, everybody I know who has pets are absolutely convinced that their pets have emotions, and
yep,
lots of people who have interacted with animals much more than I have are convinced. But I've heard some counter arguments that you could give a simpler explanation of animals' behavior just by supposing that there are more basic mechanisms like reward or threat. And so when I did that blog post on animals' emotions, I did it in the form of a dialogue because I really wasn't sure. I was trying to make the
right, right,
arguments both ways. But what really changed my mind only in the last couple of months was a book on animal grief by Barbara J. King. She's quite a distinguished anthropologist who works
hmm,
on animals, and I found that really convincing. And so once you can grant that animals feel grief, then it's pretty easy to suppose that they've also got less complicated emotions such as happiness, sadness, fear, anger, and surprise.
right, right, right. Yeah, when in prepping for this discussion, I had a few conversations with family members and friends, and it was pretty much unanimous. Folks looked at me, because I said, well, the topic of this discussion is going to be, do animals have emotions and do machines have emotions? When I brought up animals, they all looked at me almost perplexed, like, how could you not believe or know definitively that animals have feelings and emotions?
Yeah.
They almost were insulted that, well, you must not be an animal lover. So, but I
Well,
was,
the only reason I started wondering about this was I was at a conference on emotions a few years ago at Emory,
mm,
and a really distinguished group of speakers. So Franz de Waal was there, and he was giving his uh, actually quite elegant description of all the kinds of animal emotions that he studied. But one of the other speakers there was Joseph Ledoux, who's a famous emotion researcher. In fact, he made his reputation by studying what he called fear conditioning in rats. But he'd had a change of heart. He decided he was never actually studying fear in rats. He was just studying threat
Ah,
behavior.
right.
And so he said also, people talk about happiness in rats and chimpanzees, and sometimes some people even think that bees are happy. And he says, no, that's just reward behavior, a kind of behaviorist. And I didn't think he was right, but I didn't have a good counter argument to that. And so that's why I did that earlier blog post. But I left it open. I said, well, there's got to be some piece of evidence that can only be explained by the hypothesis that animals have emotions, as opposed to these
Hmm.
alternative hypotheses that it's just much more basic processes
Much
such
more
as
primitive,
reward
right?
and threat. But it was really grief that convinced me that, because I can't think of any really lower level kind of explanation for what you find in elephants and dogs and many other animals when they've lost another member of their own species, or sometimes even a member of a different species, and they're really attached to them. And so
Right,
they
right.
behave as if they're grieving. They behave in lots of ways that are similar to people. And there's no simpler explanation. So that's what really convinced me just in the last couple of months.
Yeah, and in a recent I mean, in one of the quotes from your blog, I think you had said, and this was the skeptic side. And just for the listeners, knowledge, your blog that we're referring to took the the form of a skeptic and an advocate. So you were having a conversation with yourself in a sense, right? With both sides of your, I guess, your opinion.
Yeah.
And the skeptic at one point said, behavior must be accounted for outside the reward and threat mechanisms to be considered emotional. And I think that's what you're referring to there.
Yeah,
Um,
and that's why grief was so important, because that seemed to
right,
me to be a well empirically established kind of behavior that can't really be explained except by supposing that
right,
the
right.
chimpanzees or other animals are actually experiencing grief.
Right.
So
Yep.
they're having
And
emotions.
yep, yeah, exactly. We see all these YouTube videos, and in fact, a family member just discussed with me how, they live in a more rural area, and there was a cow was giving birth, and the calf died, during the birthing process, and that the cow later spent several days just in that spot, after the little calf had died. So I could see no threat or reward or any type of explanation to something like that, more
Mhm.
akin to grief as you're defining it. Like, why was that
Yeah.
cow sitting there? He lost that cow lost an offspring, and it was grieving. That's the only thing
Uh-huh.
you can. I mean, interesting.
Yeah, but
Um,
you
so
can't always sometimes there are alternative explanations. There are lots of people who think that their dogs experience guilt because if, say, the dog is made a big mess and they shout at it, and the dog cowers its head and puts its paws
right,
over
right,
its head, and it seems to be, oh yeah, the dog really feels guilty. But there, it's interesting. People have done good experimental controls, and they find that the dog will respond in exactly the same way if if it hasn't done anything.
oh
So
really?
really, in the case of guilt, I think there's a good alternative explanation. It's basically just being submissive to avoid being punished.
Right, right, right.
So there, I don't believe that animals like dogs feel guilt, but the grief really convinced me. And if once you've got grief, then sadness and happiness and the other simpler emotions definitely go
Right.
along.
Right, right, right. Now, is it in your opinion? I mean, or does the science suggest that it's just a difference in the complexity of the brain? Is there a limited limbic system in animals versus, well, I guess some animals? I guess they're all different, but is that is there a physical difference in the brain that we're causing this distinction that we
Well, the
must
limbic
be?
system's pretty much similar across all mammals. I mean, all the animals we're talking about, cats, dogs,
Hmm.
chimpanzees, elephants, they've all got the amygdala, the striatum, nucleus accumbens, and so actually their emotional mechanisms are the same. But for some
Oh,
emotions,
okay.
you need to have a whole lot of information getting combined together. So guilt, for example, is really complicated. You got to be able to think, I did something wrong, and so
Right.
first of all, you got to have a sense of I, and it's not clear that a lot of animals have a sense of self. Uh,
Mm.
People have been doing really clever experiments where they put a mark on an animal and see if it recognizes itself in the mirror. And so
Right.
far,
Right.
that's only worked with about 10 different species of animals. It doesn't work, for example, with cats and dogs. So I think, first of all, you have to have a sense of I, and you have to have a kind of moral code to believe that you violated it.
Right.
And I don't
Right.
think you'll find that you don't in animals that don't have the same kinds of large brains and linguistic capacities that humans do. But of
Right. I mean,
course, you don't need that for basic things like happiness, sadness, and grief.
right, right, right. Yeah, I mean, is it chimpanzees, octopus? I always hear, dolphins. Are those the? I feel like those are the ones I always hear that can actually they can notice them, recognize themselves in a mirror, and they're
Yeah,
only able to.
dolphins, yes. Octopuses, no, not yet at least.
Oh, okay,
Yeah.
okay, interesting. So you've switched sides. It sounds like.
Well, no, I didn't switch sides. I was actually neutral. I mean,
Oh, okay. Yeah, yeah,
the
sure.
the
Well, you guys, you
debate.
got convinced through the
Yeah,
science. Yep.
I was actually agnostic. I didn't have an opinion one way or the other. I
Gotcha.
kind of wanted to believe that they had emotions because everybody I know who's attached to their pets
Yep. Well,
is absolutely convinced of it. But I wanted to have a good argument,
well,
and
100%. Yeah, and well, I mean, I guess a little personal, but do you grow up with animals? Do you have animals currently?
well, no, I think that's the difference. I mean, I've never had pets myself. I'm
Gotcha.
I, I'm actually quite attached to my girlfriend's cats, but but that's sort of a farther remove.
Yep, yep. Well, interesting. Well, like I was saying earlier, I when I brought this up, everyone kind of looked at me almost odd that I would ask the question about the pets. But then we started talking about machines, and they also looked at me just as perplexed, but not even knowing what I meant. And even friends that I work. My day job is in software, so
Uh-huh.
when I talk to some of my software, minded friends, they had a different level of perplexity. Said, of course, machines can think. That's what we work on every day. But I was saying, well, I'm not saying can they think. The question is more, they feel emotions. Will they eventually be able to feel emotions? What are they? And it took a turn where they kind of said, dude, you just leave that for the podcast. You're boring me. So it's kind of took a turn there, but
Yeah.
because it's interesting because I love the topic's fascinating, and I don't think folks realize the day-to-day artificial intelligence that we interact with. I think if you ask the layperson about artificial intelligence, they think of robots that are going to just battle us and win. And I'm
Mhm.
thinking, well, every Netflix, recommended movie is using artificial intelligence and machine learning to figure out what, every ad that comes up in Google. This is all, stuff. This is all software that's listening and trying to understand your behavior to give you more recommendations to make you eventually buy more stuff. So it obviously has tentacles everywhere.
Mhm. Yeah, I've been tracking artificial intelligence for a long time, much longer than I've been interested in animal cognition.
Mhm.
But it's really amazing what's happened in the last decade. Huge advances beyond what people thought were imminently possible. So driverless cars are really impressive right now. IBM's Watson is doing some really cool things, and there's just a lot of different kinds of developments, especially in deep learning, that are becoming ubiquitous. So
Yeah,
AI really has advanced dramatically in the last decade.
yeah, it has, and particularly, I mean, and I think one of your blogs, in fact, I don't remember the name of it, but you had listed um, I think you had listed a group of the current, the top. Oh yeah, it was what does the current AI stack up? How does current AI stack up against human intelligence? I think I started reading that, and I went off on all 85 different tangents. But um, the one that I've been fascinated with was the deep mind, and I think they got acquired by Google. But and if I recall right, they because the argument against AI, in terms of, oh, AI is not human thinking, was always, well, AI is programmed to do something. It's programmed to do something, and it's just, it learns only, and it only performs within a certain scope. And then comes machine learning, and the deep mind, the algorithms are a prime example of it, where it literally just watched a screen, watched the pixels. And I forgot some of the games they used, but I think it was a Tetris type game or Pong, where the only thing that the algorithms were privy to was the pixels on the screen. So excuse me. So it would just literally watch the screen and then learn how to play the game.
Mm.
And
Yeah, and the same techniques that they developed have turned out to have all sorts of interesting applications. So the most recent is StarCraft, which I don't know anything about. They've managed to get a program to learn to do that. But before that, I was just amazed that they got a program to learn to play Go because people thought that Go was too hard for
right,
computers right now.
right,
Initially, they trained it and then it played a lot against itself. But the more recent version, they didn't even bother to train it at all. It just played against itself. And then they
right,
took the same kind of program and applied it to chess. And in 4 hours of playing against itself, that was enough to get it to be better than the top computer chess program, which is better than any human.
right.
So just 4 hours of playing against itself. I mean, that is really amazing. They've also been able to apply it to protein folding, which is a really difficult computational problem in biology, and
Hmm.
doing better than any computer program was able to do before to try to figure out how proteins fold in the operations of cells. So yeah, the deep mind has done really impressive things.
So I mean, I don't think you can really talk about this stuff without being one part, one part excited and one part scared as hell. I mean,
Mm.
so I mean, I don't know. We got folks like Elon Musk and Bill Gates and I don't know. Even I think Stephen Hawking's even issued some warnings. But there's those three guys, and there's a lot that aren't in this camp. But obviously they're prominent figures, and they've expressed their fear of what's coming. Um,
But those three figures are obviously brilliant people, but none of them are artificial intelligence researchers. I don't think any of them really know what is going on in the machines, and none of them also are psychologists. So they haven't thought about what human intelligence amounts to.
mhm.
I think if you systematically compare current AI against the full range of human intelligence, it looks much less scary because there's still a lot of things that these
Right.
AI programs, which are really impressive, still can't do.
Yeah, I think I was watching a YouTube video of, oh my gosh, who was it? I wrote it down and I don't have the paper in front of me. I think it was the DeepMind CEO. He said something like, and he was describing how like I was saying earlier, you get the DeepMind algorithms were literally just watching. I don't know if it was just a camera that the algorithms were just receiving pixels or whatever, but he was just basically saying the game is watching, and I think it was Pong. I think the simple example, everyone listening will know what Pong is. At least the older folks will. But it was he basically described it as there's no initial data sets fed to this thing. It's literally when I hit t equals 0, when I start this thing, it's only viewing what you're seeing on the screen. He was doing a demo where the Pong screen was up. Um, and it basically he had said, and it showed the game, the computer, the computer playing the game was actually originally, when it first started, it was terrible, couldn't do much, and then it just started getting better and better and better, and then it basically was perfect. And he made a statement that was basically like, well, it's doing in layman's terms is exploiting. He said ruthlessly exploiting the weaknesses of its environment, of its perceived environment. So that's what in my head I'm like, wow, that's a one sentence that could for devil's advocate, playing as on the side of AI being scary is a scary sentence in itself. Just but
Well, that's a great accomplishment, but if you try to
sure,
look at all the things that human minds can do, it can do a lot more. So deep learning is learning from experience, it's learning from examples, but it doesn't go beyond experience. And we know from philosophy of science, which is my home field, that it's
hmm
really important that human thinking isn't just tied to what it experiences. We can develop theories, we can develop ideas about gravity and genes and mental representations that go way beyond what we could experience. So humans have got this capacity to develop really rich causal models that explains our experience.
right,
And
right.
that's not something that's found in current artificial intelligence systems.
Not yet, but yeah, you're exactly right. Right, there's
Yeah,
that.
I'm not
Yeah,
giving an argument that it
right,
can't
right,
be, but people who are focused on machine learning from examples aren't appreciating the capacity of humans to develop really abstract concepts that go beyond anything that you'll find in the observable world.
right. Yeah, I think it was. I forgot who said it, but the whole singularity thing. When now I don't know what is the current the singularity is. I guess the point in which computers will be smarter than people. Is that in
Yeah,
general?
Ray Kurzweil still thinks, as far as I know, that it's going to happen within a few decades. But again, it's someone who doesn't know a lot about human psychology.
Right, right,
In one of his books, he's got this idea that you just be able to put little miniature robots wandering through the brain and figure out all the synaptic connections. But there's just so much more going on in the brain. There's so much more involved in the psychology of thinking that there doesn't seem to be any technology that's going to produce the singularity. The argument in the near future, the argument is based on the exponential growth and speed of computer systems, and that's been impressive. But it isn't just a matter of having fast hardware. You need to have smart software as
right,
well.
right,
And machine learning is right now the best way to produce smart software, but that's still limited in what it can do compared to the full range of deep thinking that humans are capable of.
right. And yeah, and I mean, and you mentioned Kurzweil, so just for listeners, it's the Google's current director of engineering. And I wonder, uh, I don't know, and maybe this is being maybe pessimistic, but a lot of these folks that are making these bold claims about singularity and other things we're scared of, I feel like I'd be lying if I didn't feel like there was a small, piece of just kind of marketing and publicity in there, right? You get it if you're saying it's going to be fine, it's not a big deal. There's not a lot of focus, but if you say that there's this big thing coming, I think you tend to get a lot more, a lot more
Well,
attention.
especially if you can make it juicy and talk about the robot
Of
apocalypse, and
course,
then that gets people excited.
exactly.
Of course, everyone's seen the Terminator movies, and they
No,
suppose that
exactly right, right.
yeah.
So
So I'm certainly not saying this couldn't happen in 500 years, but the idea that AI will be that sophisticated in 20 or 30 years strikes me as just ridiculous, because there's a lot of psychological complexity that current AI systems are not incapable of reaching.
yeah, and you made a good point because my next point was going to be about if it was more of a case of just faster hardware, then I would say then and I've had a discussion with other folks in tech. The quantum computing is obviously going to it's not there yet, obviously, but the ability, the computational power with the projected anyway computational power of quantum computing is just going to be revolutionary. But to your point earlier, it's not just a matter of doing things extraordinarily faster. There's got to be that software aspect is critical. Um,
Of course. I mean, that there's an exponential growth in hardware speed, but software sometimes just gets worse, as you know from working in the field. And even Moore's law doesn't seem to be holding as the way it used to, because
yep.
now the chips are getting just down smaller and smaller, and so there's atomic level problems in increasing it. And quantum
Right.
computing might work, but there's still really big problems in getting quantum computing to be practically useful. It's hard to build quantum computers. They tend to be unstable, and you can't have a reliable computer that's going to not be stable.
Oh yeah. I mean,
So
you need them to be close to 0 Kelvin. Is that? I mean, you need to cool it. I mean, you have to. It's almost like a room full of a computer to do 2 plus 2 at this point. Um,
yeah, and they need to be free from any kind of external perturbations.
right.
And some people think that the brain is a quantum computer, but it's kind of mysterious how that could be, given that you have a messy system that gets jostled around all the time. And obviously, there are quantum mechanical properties operating at the cellular level, but whether they're the ones that are actually responsible for
Right.
intelligence isn't clear. So I am not ruling out quantum computing, but I think there are lots of problems in turning that into something that's practically useful.
Hmm. Yeah.
And as you said, even if it gets faster and faster, that doesn't by itself make it smarter and smarter,
Right.
because
Exactly. Right.
you've got to have different kinds of causal reasoning in order to have the sort of software that's going to be capable of doing what humans can do.
Right. Right. I mean, if we take a look at the at the lowest level, at the CPU level, what general computing is, at some point it breaks down to a one or a zero, a transistor opening or closing, right at the actual physical, electrical level. You can almost everything almost breaks down to a series of if thens, right? And now very complex if thens, but that being rolled up to accomplish things like AI and machine learning and deep learning, it tends to put an abstraction on top of all that's much more complicated, does it not?
If you look at what goes on in the machine learning programs found in neural networks, as in deep
Mm,
learning, it's actually more complicated than just building if-thens. So, I mean, one kind of learning could be building up if-then rules, and there are machine learning programs that do that.
hmm.
But what deep learning does, like all neural network learning programs, is actually much more statistically sophisticated. So it's dealing with probabilities rather than with general if-then statements. And so
Right, right,
if you've got a program that's trained, for example, as Facebook does, to recognize faces, you actually couldn't pull the if-thens out of it. What you could do is just get a whole bunch of complex statistical things where it could be figuring out that with a probability of 0.38, that person is Donald Trump. And so
right,
it's
right,
it's actually statistically more complicated than just if-then rules. Traditional programming languages, of course, work with if-then, but one reason that deep learning works so well with neural network learning algorithms is that it is much more statistical.
right, right, right. I was wondering how long we were going to say the Trump word. It was what, we got 28 minutes. We won't jump into there. We did a little yesterday with the other another podcast I did, but that was a little more topic appropriate. So I guess I guess the next thing that I think of when in this realm is ethics, right? The ethics of AI, and I don't know how much of that is occupied your brain recently, but I mean, I forgot what we spoke about in prior emails or when we spoke originally, but I remember listening to something. I think it was a podcast, and there's always these things about the trolley problem, the fat man problem, and and for listeners, that really what this is we're getting at is trying to understand. You know, eh, the trolley problem is really you got a train track or a trolley, I guess, is on a track, and there's five people incapacitated on the track, and there's a switch where you could, the person, the switch operator, could make a decision. Could you, if you hit the switch, the trolley would move off to the other track and kill one person, vice killing the five. And then there's all types of discussion around that. And they take polls and how many people would actually pull the lever. And there's all different variations of that, right? There's the fat man problem where you have you're above, you're above that exact situation, with this five people on a track, and the trolley is approaching that, those five people, but there's a fat man next to you that he's fat enough, and to if you push him off and kill him, he'll stop the trolley and save the five. Would you do it? It's a similar but different problem, right? So it draws a corollary to some of the artificial intelligence and ethics and morality that's built into artificial intelligence. And I think the podcast I was listening to was given it was, I think it was a driverless car example where the driverless car was approaching a car that was stopped in front of it. The car had a baby on board sign, and there was an older, whether it was a woman or man, older person, with a cane and walker, that was on the sidewalk, and the car had to make a nanosecond decision whether to slam into the car in front of it, potentially killing the baby, or whoever else is in it. But the baby on board sign was key there, or swerve and hit the older person. And then it became that conversation of, well, should AI be making that decision? Hey, you swerve right, you kill someone that's hopefully had a great long life, and they didn't have many useful years left, or do you run into the car in front of it, in front of the automated car, and potentially killing the child with which and who potentially had a much longer life ahead of it and hasn't quite lived its life yet. So interesting topic. And then it was really, well, how do you prevent those decisions being in the algorithms? And I would argue you almost can't, but um I don't know. So what are your thoughts there? Or does that, I mean,
Well, there are a whole bunch of difficult issues involving artificial intelligence and ethics.
mm,
The one we were talking about before is, do we have to worry right now about AI eradicating humanity? So that's probably the primary ethical issue that I don't think is that important right now, because AI isn't near to be doing that. But you're right that already there are driverless cars driving around places like Phoenix and Pittsburgh, and they're going to
right,
have to make decisions like that. But the first thing to recognize is that people aren't very good at these kinds of decisions either. They tend to be not very good drivers and not very good ethical drivers either, because they're not paying attention.
sure.
So the key question is not, well, how can you get AI making good ethical decisions? I mean, they just have to do it at least as well as what people do. And we already know that people aren't good at driving because they're texting, or they're talking to their friends, or they're worried about what's going
Hmm.
on with their work or their marriage. And so they're
Right.
easily distractible. So at least the driverless car has got its own full attention on what's going
Exactly
on.
right. Yep.
And these kinds of situations that found in the trolley problems are largely just very artificial. I mean, they don't actually happen in real life very often. So it's just
Hmm.
not something that's going to arise. Now, what you're going to have to do, obviously, is have some way in which the car is going to try it, to stop from running into people. But that's already problems that people are working on. So
Right.
you're
Right.
basically putting values into it. So I actually think that the trolley problems have been a really bad influence on philosophy, because they tend to be oversimplified, and they've made it harder than it really is to make ethical decisions. So I think that what you'd want to have as part of an AI program is something like what is the best sort of ethics that people do, which is the more utilitarian kind of judgment. That is, you try to figure out what's the greatest good for the greatest number. And that's a kind of calculation that the computer should be capable of making. And
Right.
so,
Right.
what the reason the trolley problems cause problems with people is that people often don't seem to be able to figure out, well, is it better to save five people uh, by killing one? Well, sometimes, yeah, that is perfectly reasonable, and a car can make that kind of calculation. People will draw back from it if they have to be the one who pushes the person over, but
Right.
that becomes and actually the psychological experiments that have been done on this haven't been very ecologically valid because it's all asking people what to imagine. There are other experiments where you make it much more realistic by putting people with virtual reality or by having them make the decisions with live animals. And they actually come closer to what I think is a reasonable one, which is, yeah, sometimes you've got to figure out that sacrificing one in order to save five is a perfectly reasonable thing to do. And I think that's the kind of consequence based reasoning that computers can do probably better than people.
Right, right. And I think the distinction, when it comes to AI versus, versus humans making choices that, I think the reason it's becoming more and more of an issue from just the blogs I read and whatnot is that, folks are looking at this as well. Somebody has to program this in. So we as people are telling the machines, here's how you will respond, kill the baby or kill the, and again, I do agree with you. Some of the pushback that you read about the trolley problem and others, I think you just articulated, which was these aren't realistic. These aren't realistic situations. So to base some of our research around these very unrealistic situations is a little bit deceiving at times, and it can distract, I think, from the science. And I think you kind of alluded to that.
Mhm.
Um,
Yeah, so it's going to be crucial for driverless cars and lots of other technologies to have them behave ethically, but I think there probably are sophisticated programming ways to bring that about.
yeah, I
But
mean,
there's lots of other ethical programs about AI that people are worried about. One of the main ones that really concerns me is that AI is becoming more and more prevalent and it's putting a lot of people out of work. And what are you
mhm,
going to do with a society where lots of people don't have jobs? So that's I think, a realistic, big ethical question. There are also very difficult questions concerning equality. And so if you make decisions based on machine learning programs, you can actually be locking in prejudices that you already have in the system. So
right,
that some companies have been using machine learning programs to try to make hiring decisions. But if they're in fields where they've mostly just hired males in the past, that's
right,
going to lock them into just hiring males. And so if you've got equality and diversity as legitimate values, as I think a system should, then the machine learning programs that go based on past experience are actually going to do things that are unethical. So there are some, I think, really substantive issues about AI
mhm.
and ethics concerned with employment and equality that are really worth worrying about.
Yeah, on a positive note on that, I'm almost hoping, using the hiring example, I'm almost hoping that it brings light to some of our implied prejudices, and then we all kind of wake up a little bit to some of that. Like, hey, you know what, maybe I mean, we have statistics, but in your example about the men versus women, perhaps it could actually help us go, you know what, while these algorithms are learning from our past behavior, and that past behavior is kind of crappy. So hope perhaps we'll actually get to that realization quicker. So I try to look
Yeah.
positive in that regard. But you're right. That's
Well, the principle in computers, garbage in, garbage
garbage.
out.
Yeah,
And so you've got to
exactly.
make sure that you've got it set up. So
I think I use
here's
that
one
term twice a
in,
week on
in,
average.
in in symphony orchestras a couple of decades ago started a practice of having blind auditions where the
Hmm,
players would play behind a screen. And so all you'd be listening to is the quality of their playing. And this resulted in a dramatic improvement in the number of women playing in symphony orchestras because you got
really?
rid of the bias.
Hmm.
And it's kind of unfortunate. Some machine learning programs for hiring have worked exactly the opposite because they're just trained on previous data. And if it just turned out in the past that the best software person you could hire was you did hire or thought you were hiring was always a male, then you've built a bias into the program instead of eliminating the bias the way that blind auditions do.
But I mean, I would even think in that particular example, wouldn't that not even be an input? I would say, I would argue, whether it's the name or the male, female, shouldn't even be an input to the program. I would think the system
Well, of
shouldn't even need
course,
to know that.
yeah, but that requires an executive decision to make sure that
Hmm.
that variable and other variables that are inappropriate, such as race, simply aren't going into the out. But if you simply feed into the machine learning program all the variables you've got and includes things like
Right.
race and sex, then you're putting yourself in a position of simply in
Right.
encouraging bias rather than working
Yep,
to
yep.
eliminate
Yeah,
it.
I've heard that argument before, and I always say the same thing. Well, the input should be if you got a resume and there's name on top and date of birth, whatever, you that doesn't go in. That has nothing to do with whether this person's qualified. Maybe date of birth for for age. If someone's 12, we're not going to hire
Mm.
them. Um, yeah, I would think now the problem comes in, and this is getting a little off topic, but not really. If the problem comes in with the algorithms do keep recommended, say, male or females in tech or in other fields or nursing, right? The two examples. In my opinion, that should be okay. If race or sex was never an input, you know,
Mm.
but I know that gets complicated because
Yeah.
there's
Well,
enough.
let me bring it back to our original topic of
Mhm.
emotions, because I actually think emotions are highly relevant to ethics. And this is something that's very worrisome about AI. When people make ethical judgments, it's not always just because they're doing some kind of calculation. Often they're doing it because they actually care about the people who are involved. And so the
Right, right,
idea
right.
of ethics is just a calculation has real limitations because that doesn't give you the motivation to actually do something about it. I think this is an idea that goes back to David Hume that and Adam Smith actually both argued that a big part of ethics is having a kind of sympathy for people. They used the word sympathy to mean empathy as well as sympathy. So it's a
Right,
kind of
right,
fellow feeling is what Adam Smith called it. And so the idea is that when you're making an ethical judgment, it's not just the abstract calculation, it's actually caring about who the people is involved. And that's where it gets problematic with respect to machines, because
right.
machines are getting smarter and smarter, but they haven't
But they don't
improved at
care.
all in the caring dimension.
Right.
There was a philosopher, John Hoagland, who said, the problem with computers, they just don't give a damn. So he was
Yeah.
pointing to the lack of motivation.
Right, right.
But this is even more serious because this is a question of actually having concern for others.
Hmm.
So if 100 or 200 or 300 years ago, we're actually getting into Terminator type situations, it's entirely possible that they'd be perfectly good at doing mechanical calculations about the greatest good for the greatest number. But if they don't actually care about people, then they're missing something that I think is a really important part of
Right.
human ethics.
Interesting. Yeah, so I wonder, I mean, in one side, after everything we've talked about, the question in my mind is, yeah, I just try to look at the trajectory of humanity, right? At the top level view, we take a step back. I feel like, and I don't know if this is a good thing or bad thing. But as humanity has evolved, right? We used to be very, very religious, right? God's lowercase G, capital G, God. It was more part of everyone's life. As we've gotten quote unquote smarter in science, and I feel like religion is on the downfall, is on the statistically dwindling. Um, and okay, so I'm thinking, okay, now and then now with the rise of quote unquote machines and machine learning and generally intelligent silicon, um, is are eventually, and I don't know what your thoughts are here, 1,000 years from now, 2,500, I don't know what the time is. Will we be just a bunch of secular things? We'll be occupying another planet. There'll be carbon based life forms, us. There'll be silicon based life form robots, and we won't be the most special thing that we thought we were maybe thousands of years prior. That might be a little bit dire of a. I guess it doesn't have to be dire, but it scares me on some sense, but it's also intriguing as heck on another. Um,
Well, but that trend's been going on for a long time. And Copernicus
right, right,
messed things up by suggesting that, well, no, the Earth wasn't the center of the universe. And then Darwin
right,
came along and
exactly,
showed quite convincingly that the human species wasn't extraordinarily special. It evolved like all the others.
right,
And of course, now we got cognitive neuroscience providing more and more evidence that the mind isn't anything spiritual
exactly,
or immortal. It's another kind of biological physical process. So that kind of demotion of humans from being the center of the universe has been going on
right, right,
for
right,
hundreds of years. Frankly, I don't find that particularly disturbing. The sort of things I find disturbing are that humans could actually destroy the planet through climate change and other kinds of ecological disasters. So
right, right,
those I think are really serious imminent problems that are things we have to worry about over the next few decades. And the other problems that are centuries ahead, I can't get too worried about. I mean,
right,
there's no point in worrying about the existential questions if the planet's uninhabitable 100 years from now.
Right, right, right,
And
right.
the trend there is just really bad. There's just so much growing scientific evidence that within a matter of a few decades, larger and larger parts of the planet are going to be very difficult places to inhabit.
Yeah, I think that whole theme. Not to, we're gonna get a tiny bit political here, but I think that whole theme of global warming is a hoax. I feel like that's dying. Is that dying? I mean, it should be, but is it? I mean, I feel
Well,
like it's slowly going away. I'm not. I don't watch the news nearly as much as I used to. I find it nauseating at times, and I just can't. But I tend to be exactly in your camp here, where all right, come on,
yeah.
could we ignore science any more blatantly? But I don't know.
No, I think the evidence is overwhelming, but there's a lot of people who, for either political or sometimes for religious reasons, are highly motivated to ignore the evidence.
Yeah, yeah. There's a lot of we all have a lot of blind spots, and one of the motivations for me to start this podcast was exactly to illuminate my own blind spots and grow as a person. And speaking to folks like you and others, it's already starting to do that. So I it's just it's excellent. I love it. Um, so I, I guess for what do you have going on? I mean, we talked about a lot of stuff. Anything we didn't touch on that you think is really poignant to this topic that we should circle back on?
Well, but the ethical questions are really interesting with respect to machines, but they're also really interesting with respect to animals.
Hmm.
So I'm writing a book right now called Bots and Beasts, which is going to be about both machines and about animals. And I haven't got yet to the last two chapters, but they're going to be on these ethical questions,
Huh.
one chapter on machines and one chapter on animals. But once you start appreciating that animals have much more sophisticated brains and minds than was thought before, then a lot of important ethical issues arise about them also,
Hmm.
such as, for example, should you eat them? And other issues are concerning
Right.
this treatment of animals. So what I've been doing, really,
You're
I've
not taking
already
away my
done it.
mistakes, are you? Is that your book's going to do? Because I'd love to recommend it here, but
Well, I think you should be thinking about what's going on to the cows that happen to get eaten. One of the
Amen.
things
No,
that,
amen on that.
uh,
But
uh,
yep, I 100% agree there. But you can drive yourself
uh,
nuts in that world and trying to find out what happens. I mean, I tell my
uh,
wife all the time, I'd love to have my own. I'd love to be able to grow and kill everything that I eat. I would love to, but unfortunately, life gets in the way
well,
of my
that would
reality.
be if you raised it nicely. That would
Exactly. Oh,
probably be good.
absolutely.
Yeah.
Right. Right.
And your steaks may eventually be able to produced in factories in New Jersey just from
Manufactured
cell
meat. Right. It's
cultures. Yeah.
happening. Yeah, it's going to happen. Yep. Yep.
But there's just really important ethical questions about animals as well as machines.
Yeah. No. So when is that book coming out?
Oh, I'm just writing it now. It's going to take me another year to have something that I can even go to a publisher with.
Okay. Okay. So you just okay. You said you got to finish the
But
first
it's been
chapter.
really interesting to go back and forth, in fact, between the looking at the animals and also looking at the machines. Even looking at simple animals, I'm realizing that there are kinds of learning that dogs and cats and chimps are capable of that no computer can do. So here's an example. Here's a wonderful anecdote I just read about. There's a bay in Australia where they were really surprised to see that the wild dolphins swimming in it could walk on their tails. They would just fly out of the water and walk along on their tails. And this has never been seen in wild dolphins before. So, how did that ever happen? Well, it turned out that one of the dolphins had been, for a little bit of time, looked after in a dolphinarium where it had observed other dolphins that had been trained to walk on their tails to amuse the audience. So this dolphin had
Interesting.
learned to do it by imitation. And then the other dolphins in this bay had learned how to do it by imitating this dolphin. Now,
Wow.
it turns out learning by imitation is really common in the animal kingdom.
Hmm.
And learning by imitation is just a really great way of learning because it's fast. You can do it really pretty quickly. So if a chimp sees another chimp crack open a nut with a rock, it doesn't take a lot of trials before it can figure out, oh, I can do that too.
Right. Right.
And so you find imitation, and of course, for people, it's really important. You want to be able to not just give some people written instructions, but say, "Hey, look, here's how you do it."
Right.
Whether it's shooting a hockey puck or cracking a nut open, this kind of imitation learning is really important. And I don't know of any actual computer model of this, and I don't know. It's really actually more complicated than it seems because you've got to have a sense of how you do things with your body, with your hands.
Right.
It's
Right.
got to
Right.
have you got to also have a sense of causality of what causes what. The fact that when you hit the rock, use the rock to hit the nut, you're causing the nut to crack open. And
Right.
no computer now has an understanding of causality, something you find in human infants by the age of about 2.5 months. So this is, I think, a really important insight from understanding the biology of cognition, that there are aspects of thought that AI hasn't looked at. So I don't have any argument that AI couldn't do that,
Right.
but
Right.
it's certainly not going to get that just by giving it a million examples of changes taking place in the world, which computers can do right now. But there's something else that's involved in being able to learn by imitation and have a causal understanding of what's going on in the world. So you can learn not in a thousand or a million trials, the way that deep learning usually operates, but by just one or two trials,
Right.
the way
Right.
that people are often quite capable of.
There's some thread of processing that's happening in our minds and these animal minds that we can't necessarily grasp yet and program or
Exactly.
yeah. No,
Yeah.
I was
Because
gonna when you first started speaking about that, I was gonna say, well, isn't my initial impression was, isn't that just what DeepMind does? That our initial example, it looks at a screen and learns, but maybe it's almost like, to your point, it would be like a deep mind watching another deep mind, and that deep mind's watching the screen learning. So it's almost like the deep mind observer would have to be observing its fellow dolphin, if you will, and that it's almost like a second deep mind watching the primary one learn. So then it could then imitate
yeah,
how it learned, which is a whole nother level of complexity. I mean, I can't even wrap my head around, but um, that would be an entirely new level.
yeah, and people may develop that, but it's not something that's currently within the range of machine learning programs.
Hmm, fascinating, it really is. Dolphins on their tails walking. That image is. Can I find this online? Like, I mean,
Oh, I'm sure if you Google it, you'll find
I've
it
never
because
seen that. That's
they're
fascinating.
trained to do it, and so this is where people have to reward dolphins to be able to do this on demand. But the
Right,
fact
right,
that lots of learning in the wild takes place without that kind of training, without kinds of reinforcement, or without zillions of patterns that get
right,
recognized,
exactly, right,
it's just, oh, you see somebody doing it once, and you realize, oh, that's a good thing to do.
right.
I find the same thing when I've got instructions for a new kind of machine. You can read the instructions and look at the pictures and try to figure it out. But if you can find a YouTube video that shows somebody actually moving their hands in a way that shows how the pieces fit together, it's
Oh
just
yeah,
way
for sure.
faster to figure out what's going on.
Oh, absolutely, absolutely.
So learning, imitation learning, I think is something I didn't realize until fairly recently, a very important kind of learning in humans and other animals, and potentially could be really valuable for AI, but it's not been much investigated as far as I know.
Hmm. Yeah, fascinating. I mean, there's enough content here. I think we left on the table for another episode, but I think we hit about an hour. I mean, where can folks find you, and what do you got? You mentioned your one book that's a ways out. What else do you have out there that folks should pick up?
Well, the easiest way to find me is my website, which is paulthagard.com,
Okay,
and so that's easy to get to. But by far the best is the book, just actually the set of books just published this month, Brain Mind, Mind Society, and Natural Philosophy. They're going to be available by the end of February, and they're from Oxford University Press, and they're a really comprehensive set of studies concerning how the mind works, how the brain works, and applications this has to many different areas, such as law and education
hmm,
and business. Especially Mind Society has got loads of applied ideas there. So I think that these books that collectively I call the Treatise on Mind and Society are a good place for people to look. But the information about that and lots of other things I've done are all on paulthagard.com.
excellent. Yeah, I dug into those a little bit. You sent me that link, and I read the summary. They seem fascinating. I think they must read for
But if
anyone.
people want a kind of lighter introduction to what I do, the blog that I do for Psychology Today called Hot Thought is gets a lot of viewers, and the pieces in there are quite concise and they're written for a general audience, and so people will probably find some topics in there that they want to dip into.
Yeah, I would 100% agree with that. Yep, and in fact, that's I think that's how we opened this discussion. That's how I found you, and I read probably 5 or 6 of your blogs before I said I gotta talk to this guy. It was just fascinating, well written. And you're right, concise. You can read them while you're at lunch and just ponder on it the rest of the day at work while you're not working, thinking about what you just read. um, but anyway, Dr. Thagard, thank you. Appreciate your time. We'll have all the stuff you just mentioned, where to find you, and I'll put that in the show notes so the listeners can find you pretty quickly. But with that, I appreciate your time. Thank you.
Oh, thanks very much for a really interesting conversation.
That's pretty much it. Thank you for listening. I enjoyed that. I hope you got something out of it and got you thinking a little bit. This is Vinny from Unlatched Mind. We'll see you next time. Thanks.